2.2.6 Infrastructure as Code, Terraform, Conceptual Model. By now, we have a pipeline that can move code from a laptop to production. We build artifacts, we test them, we know how to release them with control. But there is still a quiet source of risk sitting underneath all of that. Environments. Somewhere, your application needs a place to live. There are servers or containers. There are networks and subnets. There are databases, queues, load balancers, firewalls. For a long time, these things were created by hand. Someone would log into a cloud console, click through a wizard, choose a region, pick an instance size, type a name, open a port, maybe copy a configuration from staging to production, and hope they didn't miss a step. It worked, until one day it didn't. Staging would look fine. Production would behave strangely, and eventually someone would say the sentence every engineer learns to hate. Maybe those two environments aren't actually the same. That pain is where infrastructure as code begins. Infrastructure as code, or IAC, starts from a very simple idea. If we already treat application code as something we write, store in Git, review and version, why don't we treat infrastructure the same way? Instead of saying this server exists because someone clicked it into existence last year, we write down what that server should look like in a file. Instead of this network kind of happened over time, we describe the network in code. Those files live in the repository next to the application. They are reviewed like any other change. They have history. They can be rolled back. Suddenly, infrastructure is no longer a vague memory of what someone configured. It becomes an explicit, repeatable description. Terraform is one of the most common tools teams use to make that description real. Terraform does not ask you to describe every button you would click in a cloud console. It asks a different question. Tell me what you want the end state of your infrastructure to be. You tell it, in configuration files, that there should be a virtual network, that inside that network there should be a database, that a group of application instances should run in a certain region, and that a load balancer should sit in front of them. You are not scripting the steps, you are describing the outcome. That is the declarative model. Old-style scripts are imperative. They say, create this server, then configure it like this, then attach this disk, then open this port. If you run them twice, they might try to recreate things that already exist, or fail halfway through, or leave your environment in a strange, half-finished state. Terraform works differently. It keeps a picture of what the infrastructure looks like today. It compares that picture with what you told it you want. And then it creates a plan that says, in effect, to get from here to there, I will create these resources, change these, and remove these. You get to look at that plan before anything happens. If it makes sense, you approve it. If it doesn't, you adjust the configuration. Under the hood, Terraform talks to different platforms through small plugins called providers. One provider knows how to speak to AWS, another knows Azure, another knows Google Cloud, others speak to Kubernetes, DNS services, and even some SaaS systems. From your point of view, you stay in one language. Terraform translates your desired state into the right API calls for each platform. That is why people say Terraform is cloud agnostic. You're not locked into one vendor's template format. You describe the shape of your infrastructure once, and providers know how to turn that description into reality on different backends. There is another important piece in this model: state. Terraform keeps track of which real resources in the world belong to which lines of configuration. When you add a new block to the configuration, Terraform knows it needs to create something new. When you remove a block, Terraform knows there is now a resource that should probably be destroyed. When you change a parameter, Terraform knows it must update the corresponding object. Because the configuration files live in version control, state is not just a snapshot of machines. It is part of a story. You can see, commit by commit, how the infrastructure has evolved. You can see who added a database, who changed a subnet, who opened a port. If a change introduces risk, you can revert the configuration and apply it again, just like rolling back application code. That shift has deep consequences. Creating a new environment, for example, becomes much less dramatic. Instead of saying, we need 2 weeks to set up a new staging system, a team can say, run the same Terraform configuration in a different workspace or account, and you get an environment with the same shape as production. By design, not by luck. Drift, the slow divergence between environments, loses its power. If someone tweaks a setting manually in a console, the next Terraform plan will show the difference. Nothing is invisible anymore. Infrastructure as code also changes how teams collaborate. Because infrastructure is written as code, it can be reviewed. A pull request that changes a security group or opens a new port can be discussed before it ever reaches the cloud. People can ask, why are we exposing this? Or, should this database really be public? Those conversations happen early, on files, not late, on misbehaving servers. All of this sits very naturally next to CI/CD. The same pipeline that builds and tests your application can also run Terraform in a controlled way. You commit a change to infrastructure. The pipeline runs a Terraform plan. It shows you what would change. Someone approves. Terraform applies the plan. And your environments evolve with the same discipline as your code. There are, of course, misunderstandings around infrastructure as code in Terraform. Some people think it's just fancy scripting. But the real power is not in automating clicks. It is in having one clear versioned description of the whole system. Others worry that infrastructure as code will replace operations teams. In practice, it does the opposite. It gives operations engineers a better language to express their expertise, and it gives developers a clearer understanding of how their application lives in the real world. Used well, infrastructure as code doesn't remove responsibility. It makes responsibility visible. If someone asked you in an interview what Terraform and infrastructure as code actually bring to a CI/CD setup, a strong answer would sound calm and concrete. They let us describe infrastructure in code, keep it in version control, and reproduce environments reliably. Terraform compares what exists with what we want, calculates a safe plan, and applies it. That means our dev, staging, and production environments can be kept consistent, changes are reviewable, and rollbacks are possible, just like with application code. At that point, environments stop being mysterious snowflakes. They become part of the same engineering discipline as everything else. And once you start treating infrastructure this way, a new question appears almost immediately. If we can define servers, networks, and databases as code, what about the configuration that sits on top of them? The settings, templates, and charts that tell our applications how to behave in those environments. That question leads us directly into the next topic, configuration as code, and why tools like Ansible and Helm matter. End of 2.2.5.